Hello dear friends, let's talk about problems of Audi Q7. The 3.0 TDI turbo diesel with 6 cylinders is known from the A4, A6 and A8 models, which is characterized by power even at low revs, very good dynamics, especially in A4 and A6. You will also be satisfied with cultivated work and sound acceleration. In the large and almost 2.5-ton Audi Q7, the engine dynamics are obviously weaker, most noticeable in all three 3.0 TDI engines of 150 kW and 155 kW, both for 150 Nm and the oldest version of 171 kW. 500 Newton meters. For normal driving, however, the engine is sufficient best dynamics between 2000-3500 rpm. The average fuel consumption is about 11 to 12 liters with a power output of 176 kW, 550 Newton meters, or 180 kW is on average 1 to 1.5 liters less. On the design side, the 3.0 TDI engine was gradually upgraded during the production of the Audi Q7, with the most significant change in 2010-180 kW/150 kW. The displacement of 2967 cc remains the same. However, the engine itself has undergone a complete change. There is a new cylinder block, crankshaft, forged pistons, aluminum connecting rods, cylinder head and suction. In a sense, the internal aerodynamics of the cylinders have been redesigned. The main goal of the designer was to reduce friction loss as much as possible in order to reduce fuel consumption. The drive mechanism was also revised, where 4 chains replaced 2 chains. The engine also reduced the weight of the engine by 25 kilograms, and thanks to a more economical drive mechanism, the length of the engine was reduced by 100 millimeters. Internal friction is also reduced. Fuel injection is provided by a 4th-generation common rail with 8 piezo injectors operating at pressures up to 2000 bar. The turbocharger also underwent a modification which had a positive effect on acceleration at low engine speeds. The modified intake pipe has only 2 instead of 6 wings, which means that only one wing regulates the air flow for one row of cylinder, 3 cylinders. It should be added that the older version of 171 kW is delivered without a soot particle filter as standard, but is available at an additional cost. It may happen especially in the case of importing the Audi Q7 from Western European countries, that a vehicle with this engine will be equipped with the DPF. The new version with 176 kQ already has a DPF filter as standard. In 2009, an environmentally friendly version of the 3.0 TDI V6 engine, also known as clean diesel, was launched on the market. Thanks to advanced nitrogen oxide elimination technology, injection of AdBlue urea additives into the SCR catalyst, this version complies with the Euro 6 standard. The reliability of the engine is quite satisfactory, but it is necessary to know and possibly eliminate some weak points. As the number of kilometers increases, problems with the drive chain mechanism appear. Problems with the chain tensioners will lead to chain loosening and chain vibration and further chain towing. Excessively loose chain is usually manifested by the sound of the chain rattling at idle. Especially after a cold start, it gradually begins to be heard even at rest, even when the engine is warmed up at low speeds. These sounds are not worth underestimating because they are neglected, and further pulling of the chain can lead to skipping the chain and later fatal damage to the engine. It should be added that the drive chain is more sensitive in the case of older version of the engine. And with newer two-chain engines, 180 HP/150 kW, the drive mechanisms are much more durable. Changing the chain is financially very demanding. It greatly increases the work because the chain is on the gearbox side in all versions, and it is necessary to remove the engine from the vehicle. An even more sensitive point are the intake valves. Older engines have 6 flaps that get stuck due to soot deposits, which is mainly reflected by the engine light coming on, increasing consumption and fluctuating power. Occasionally there is a problem with the servo motor, which is overloaded by starting the valves on which the soot is depositing. There is also excessive wear on the valve spindles, which causes sounds and over time jams. Newer engines of 180 kW/150 kW have only 2 valves. A smaller number in this case means less problems, because their construction is more robust and they resist traps better than soot deposits. If driving more frequently over shorter distances, there is an increased risk of a EGR valve or DPF filter problem/blockage. EGR valve problems usually occur in the form of an engine light, loss of power or switch to safe mode. Engine life turbocharger and injection system also affect the lifespan of the DPF, in addition to driving mode. The turbocharger is relatively durable. Leakage occurs in the EGR cooler due to the porosity of the material. The coolant thus enters the engine, where it burns with the diesel. Incineration is not optimal and causes problems with the EGR valve and DPF filter. Occasionally, fluid leakage also occurs through the engine's thermal energy control valve, the manifold leading to the EGR circuit cooler, and sometimes the oil module. Water falls into the interior space between the rows V engine linders. There is also an oil leak, usually in the gearbox area. Engine oil leaks at the crankshaft to the transmission. Problems with the high-pressure injectors or pumps usually only occur with higher mileage. Audi Q7 4.2 TDI. Another diesel on offer is the 8-cylinder 4.2 TDI with maximum 240 kW, or after the upgrade 250 kW with the same maximum torque of 714 Nm, which is available at higher speeds in the case of the new version. The engine gives the Audi Q7 really decent dynamics regardless of the number of passengers or the size of the luggage. The improved 250 kW version has improved lower engine power and less turbo effect by increasing engine power. In practice, the vehicle begins to accelerate rapidly at about 1200 rpm, with acceleration followed by a dull sound. The older engine is a bit slower with slower speeds, but the increasing torque increases significantly with increasing speeds. Consumption is on average about 12 to 13 liters. The reliability of the 4.2 TDI is slightly worse than the 3.0 TDI. which is generally a higher use of engine performance and often less quality service, especially for the other owners, and also more complex/advanced technology. 8 cylinders, 8 injectors and heaters. The engine has 2 turbochargers, 2 air coolers, and also 2 soot particle filters. For example, if one turbocharger fails and another turbocharger needs to be replaced/refurbished in pairs to properly balance the charge pressure in the 2 rows of cylinder. All repairs are even more complex compared to the 3.0 TDI due to the compactness and specific configuration of the engine, and it is often necessary to remove the engine from the vehicle. It is unnecessary to forget the higher weight, which, in addition to the impact on the driving performance of the vehicle, and also affects the somewhat faster wear of the chassis components. 6.0 TDI. The top of the diesel offer is 6.0 TDI V12 with maximum 368 kW and 1000 Nm of torque. The engine was developed by the sports department of the Audi Quattro GmbH, currently renamed Audi Sport. The engine has 2 rows of 6 cylinders arranged in V, but instead of the conventional 90 degrees, the angles are only 60 degrees. The engine is powered by 4 chains. The engine contains a pair of turbochargers. Fuel injection into the cylinders provides 12 piezo nozzles with a pressure of 2000 bar. Acceleration from 0 to 100 km per hour in 5.5 seconds, and top speed is electronically limited as standard at 250 km per hour. The driving dynamics are really exciting with this car, but the driver needs to be prepared for more unpredictability and difficulty due to the heavy front of the vehicle. Consumption ranges from 14 to 15 liters per 100 kilometers in normal use. Audi Q7 petrol engines. Gasoline engines, in the case of Audi Q7, play a secondary role. The base is 3.6 FSI with max, with a power of 206 kW and a torque of 316 Nm. Structurally, it is an evolution of the legendary 2.6 VW6 VR 1992, which had a Golf 3 or Sharon under the hood. The head is common to both rows of cylinder, and the angle of the cylinders is only 10 and 6 degrees. The engine has FSI direct fuel injection, variable regulation of intake and exhaust valves. Despite the solid performance of the engine with the Audi Q7 has a lot of work, which is most pronounced during acceleration at lower speeds. For faster acceleration, there is, therefore, a need to keep the engine at higher speeds, which is of course reflected in the increase in average consumption, which in normal driving is about 12 to 13 liters. In calmer driving, it can fall below 10 liters. With more frequent driving in the city or agile driving on the highway, it grows up to 15 liters. Much more sovereign is the larger 8-cylinder 4.2 FSI with max 247 kW and torque of 440 Nm. The engine has less work than 3 and 6 FSI, which is especially noticeable at lower RPM. Consumption is about 14 to 16 liters in normal use, with better driving dynamics, of course. In the middle of 2010, both gasoline engines replaced the new 6-cylinder 3.0-liter TFSI 837 series with mechanical compressors, which were delivered in two power versions: 200 kW, 400 Nm, and 245 kW, 440 Nm. In practice, the engine starts at low speeds, with a consequent increase in thrust. Consumption is slightly more dependent on driving dynamics than older FSI engines, usually around 12 to 13 liters. There is Tiptronic automatic transmission with 6 gears and since 2009 8 gears of the same name, Tiptronic. In both cases, it is a classical automatic transmission with a hydraulic torque converter with the possibility of optional speed vanes on the steering wheel. But these are mostly unnecessary because the actual transmission is relatively fast and logical, and the driver rarely has a reason to change speed. The new 8-speed is automatically a little faster, trying to lock the inverter and generally efficiently use the potential of the motor. As a result, it is only slightly better driving dynamics, but also slightly lower average consumption. The reliability of both transmissions is maintained in good condition, with regular oil changes and normal use of the vehicle. If maintenance is neglected in the gearbox, valves, mechanics, etc., impurities contained in the oil will accumulate faster, which will negatively affect the performance and overall durability. For the older 6-speed transmission combined with a diesel engine, especially the 60 TDI, frequent overloading with driving dynamics leads to gearbox breaks. Audi Q7 – reliability and the most common problems. With large and expensive cars, higher operating costs are normal. This applies not only to fuel but also to servicing. In the case of the first owners, most of the service was not a problem and the vehicles were properly serviced by authorized services. This is a significantly different situation with the next owners. It saves on a large part of the service, which of course negatively affects the condition of the vehicle. In case of purchase Audi Q7, service history and previous owners' habits are very important. Poor servicing on the previous owner is costly later. Problems with electrical equipment may include non-functional MMI control unit, non-Bluetooth door locks, key touch sensor in keyless versions, rear door jamming, or mirror heater failure. It is also necessary to check the effect of xenon headlights. There are occasional handbrake problems due to weaker spring return effects or uneven effects. On older models, corrosion can occur, most often on the chassis and bottom of the door. Gasoline engines are characterized by reliability, but it is recommended to follow certain principles of operation and service. First of all, change the oil to 15,000 kilometers, at the latest 20,000 kilometers if you drive more on longer routes. It is recommended that you do not neglect the replacement of spark plugs and replace them by 50,000 kilometers. Otherwise, an overvoltage occurs at the spark plugs, which causes a malfunction of the ignition coils. Meanwhile, problems with the ignition coils are manifested by uneven work on the smaller cylinders and weaker engine power. With TFSI, FSI motors, more soot builds up in the engine itself or in the intake. The increased amount and soot deposits in the engine generally indicate long intervals between oil changes. Soot deposit in the intake and valves are caused by direct injection. The result is a gradual reduction in engine power and poorer performance, as well as a risk of valve overheating and increased wear on the drive itself. In addition to the timely replacement of engine oil, it is recommended to refill with high-quality gasoline or regularly add at least once every 3-5,000 kilometers cleaning additives. Additives also help injectors that are less dirty and reduce the risk of their failure, especially if the maintenance intervals and services are neglected. The hydraulic lifters may become clogged with dirt. These problems occurs gradually, the engine power decreases, the engine oscillates in idle speed. Then the loss of engine power, damaged valves, wear of the crankshaft, and increased oil consumption. Exceeding service intervals or using unsuitable oil gradually leads to excessive wear of the drive mechanism. It stretches faster and increases the noise of the chains and also clogs the variable valves control mechanism. This is usually manifested by noisier operation and improper operation of the engine, especially at lower speeds, or error messages, engine light bulbs, and loss of power. In the event of a leak, a water pump may also leak. The problem with lambda props or catalyst usually occurs after a long mileage. In the case of a diesel engine, problems are caused by towing the drive chain, which usually occurs by rattling at idle, especially after a cold start. Gradually begins to rattle the chain at idle even when the engine warms up and at lower speeds. Due to larger or more frequent driving around the city, there is a problem with the EGR valve, which manifests itself in the car with less traction, uneven operation, or going into safety mode, along with the ignition of the engine warning lamp. The EGR valve can fail and leak water into the EGR valve glasses. Coolant is lost. It penetrates the intake and then burns in the engine, which has negative consequences for EGR and DPF. Typical problems of modern diesel engines, such as excessively worn injectors, rough and uneven work, poor start, etc., and worn-out turbocharger usually occur after higher mileage. Problems with the turbine sometimes occur in the non-functional regulation of the blades, which is under the control of the servomotor. At higher mileages, usually over 250,000 kilometers, there may be a problem with a dirty DPF filter. Shorter service life occurs, especially when the vehicle is driven on shorter distance and the filter does not have time to regenerate. There is also the problem of oil leakage around the rear crankshaft sealing. This shortcoming occurs more often with the 3.0 TDI, and repair is quite demanding because the engine must be dismantled, removed from the vehicle. At higher mileages, neglected services, or when towing heavy trailers or more frequent driving on difficult terrain, they can cause automatic transmission failures, which is usually manifested by chopping in driving, shocks, or gearbox failures. Neglect of maintenance, oil change, results in faster wear of the 4x4 drive and differential.